Hey everyone, and welcome to another deep dive. This time we're going deep into something truly mind-boggling, time travel paradoxes.
Time travel, yeah.
You guys have sent over a whole bunch of sources on the topic.
Lots of stuff.
And these sources are not just your typical sci-fi what-ifs. These are actual models, theories, equations.
The real deal.
The real deal, yeah. Trying to figure out if messing with the past is even possible.
Right, and I think what's so fascinating about these sources in particular is that they kind of go beyond just those, typical what if you kill your grandfather paradoxes.
Right.
They explore how, the very structure of time and space itself might allow for time travel while resolving those famous contradictions. So, could there be something baked into the universe that allows for this to happen without completely breaking reality?
Okay, so that already sounds pretty intense. I'm guessing we need like a crash course in theoretical physics to understand any of this?
Well, not necessarily.
Okay, good.
We can use analogies and kind of thought experiments to grasp the main ideas.
Okay.
So for instance, imagine a flat sheet of paper.
Okay.
Now, instead of just length and width, picture this sheet representing time and space. So that's our simplified universe for now.
Gotcha.
And this model, it's actually called the Twisted Deutsch-Politzer Space, or TDP Space for short.
Catchy.
It's like a blueprint for a theoretical wormhole time machine.
Oh, okay. So the paper is like a map of time and space.
Yeah.
And a wormhole is like a shortcut connecting 2 points on that map.
Exactly.
Okay, I'm with you so far.
But there's a twist, literally.
Oh, no.
When something travels through this wormhole, it comes out in the past, sure.
All right.
But it's also traveling in the opposite spatial direction.
So it's like going back in time, but everything is flipped, like looking in a mirror?
Precisely.
Ricky.
Now, to understand how this leads to paradoxes, we got to add some rules to our simplified universe. Think of it like setting up a game with specific instructions.
Okay, game on. What are the rules?
All right, so the research you sent over introduces something called Krasnikov's paradox model.
Okay.
And it uses this TDP space, and it imagines these particles.
Okay.
They're constantly zipping around at the speed of light.
Uh-huh.
And when these particles collide, they bounce off each other and they change color, kind of like a cosmic game of bumper cars.
Got it. So we got a map of space and time.
Right.
We've got shortcuts through time. And now we've got particles bouncing around like bumper cars.
It's a lot.
This is already making my head spin.
And here's where the paradoxes come in.
Uh-oh.
Let's say one of these particles, right?
Okay.
It goes through the wormhole. It ends up on a path.
Yeah.
But it's leading it right back into the wormhole again. So it gets trapped in this infinite loop.
So it's constantly traveling back in time.
Right.
Creating like a never-ending cycle.
That's the essence of what we call the Bootstrap Paradox.
Okay.
The particle just exists within the loop. There's no origin point.
Oh, wow.
It seemingly appears from nowhere. It's a self-creating time loop.
That already sounds like a headache for physics. Is there more?
Oh, there's more. Remember the color-changing collisions?
Yeah.
Well, if our looping particle starts as blue,
Uh-huh.
and it bumps into a red particle coming from outside the loop,
Okay.
they both have to change color, right? Those are the rules.
Right.
The red particle, it could become green, no problem.
Okay.
But our blue particle that's stuck in the loop,
Right.
it has to end up blue again
Yeah.
for the cycle to continue. So
Yeah.
the rules say it must change color,
Right.
but it also has to stay the same color.
So there's no possible color that works for that looping particle.
Exactly.
It's like a cosmic game of musical chairs where someone always gets left standing.
That's a great analogy. This is called the consistency paradox. It shows that even with a simple set of rules, time travel creates these situations where
Yeah.
the laws of physics just break down. It highlights the conflict between cause and effect and the very idea of traveling to the past.
All right, so we've got these two paradoxes, bootstrap and consistency.
Yep.
Both stemming from this time loop setup. So how do we get around these mind-bending issues?
That's where things get even more interesting. The research you provided suggests that maybe the key to solving these paradoxes lies in the concept of multiple histories or timelines.
So instead of one fixed timeline, there are multiple versions of reality branching off?
Yeah.
Kind of like those choose-your-own-adventure books.
Yeah, that's a great way to think about it.
Okay.
Imagine each time travel event creates a new branch of reality, a separate timeline. So changing the past in one timeline,
Right.
it doesn't erase your present in another.
Okay.
And there are actually two main ways that you can visualize this.
Okay, I'm ready for my mind to be blown. Lay it on me.
All right, first, picture a tree trunk, right?
Okay.
It represents that initial timeline.
Gotcha.
Each time travel event, it causes a new branch to sprout, creating a new reality.
Okay.
The second way to visualize this is through the concept of covering space.
Okay.
Now, imagine a stack of pancakes.
I love pancakes.
Each pancake is a different timeline,
Okay.
and wormholes, they act like syrup,
Oh,
connecting those pancakes so you can travel between them.
okay.
So those are our two main models. branching timelines, and covering space.
So we could have infinite branching timelines like a massive tree, or we could have multiple timelines stacked like pancakes with wormhole syrup connecting them. It's like the universe is constantly multiplying or layering itself.
Exactly. And this leads to some pretty wild possibilities, which we'll explore further in the next part of our deep dive. Welcome back to our deep dive into time travel paradoxes.
I'm ready for more?
We were picturing timelines branching out like a tree
Uh-huh.
or stacked like pancakes connected by wormhole syrup.
Yes, it was delicious.
But how does having multiple timelines actually solve those pesky bootstrap and consistency problems?
Yeah, that's a good question. It seems like it would just make things even more complicated.
Well, with unlimited histories, right, those paradoxes, they kind of vanish.
They vanish, poof.
Because a particle traveling through time can never actually complete a closed loop.
Oh, okay.
It keeps jumping to a new timeline with each trip.
So it can never run into itself in the past.
Yeah. Imagine it like this. Every time the particle is about to run into itself in the past, it shifts to a new pancake, a new version of reality.
I like this analogy.
Preventing that paradox.
Okay, so it's like the universe is constantly creating escape routes for these time-traveling particles,
Exactly.
ensuring they never create those troublesome loops.
But here's where it gets philosophically tricky.
Uh-oh.
If you're constantly jumping to a new timeline,
Yeah.
can you really call it time travel?
That's a good point.
You're never actually returning to a history you've already visited.
It's like visiting a new city every time you step back in time.
Right.
You're exploring, but you can never retrace your steps.
Precisely. So it challenges our very notion of what it means to travel through time.
Okay.
So unlimited histories, they solve the paradoxes, but they raise questions about the nature of time travel itself.
So what if, instead of infinite pancakes,
Okay.
we had a limited stack?
Right.
What if the timelines were cyclical, meaning you could eventually loop back to your starting point?
That's where things get really interesting.
Okay.
The research you provided actually explores this, the concept of finite cyclical histories.
Okay, so our stack of pancakes.
Yes.
But this time, the syrup not only connects pancakes above and below, it also loops back around,
Right.
connecting the top pancake to the bottom one.
It's like a cosmic merry-go-round of timelines.
You keep going around and around, revisiting the same set of histories.
Exactly. And the research found something remarkable about these cyclical histories.
Oh.
Remember how in Krasnikov's model, particles have specific colors?
Yeah, like our blue particle from before.
Right. Well, it turns out that with a set number of colors, let's say 5, and a set number of histories,
Okay.
paradoxes can be completely avoided only if the number of colors divides evenly into the number of histories.
Hold on. So the number of colors has to fit perfectly into the number of timelines. Like 5 colors and 5 histories, good. 5 colors and 7 histories, paradox city.
If it doesn't divide evenly, you run into those consistency paradoxes again.
Oh, no.
It's as if the universe has a specific set of rules governing how these timelines interact.
Okay.
And the math has to work out for everything to remain consistent.
It's like a cosmic Sudoku puzzle where you have to fill in all the numbers just right.
And here's the truly mind-blowing part.
Hit me.
This idea of finite cyclic histories actually connects to a famous concept in physics called the Novikov Self-Consistency Conjecture.
Wait, haven't we talked about that before? That idea that you can't actually change the past in any meaningful way?
You got it.
Like if you went back in time to stop a disaster, you'd somehow end up causing it instead.
The Novikov conjecture typically assumes just a single timeline. But this research suggests that we might be able to extend it to work with multiple cyclical histories.
So you're saying that even with multiple timelines, there might still be a sort of cosmic safeguard preventing us from truly altering the past.
Yeah, it's like a grand cosmic play where the script is already written,
Okay.
but it's being performed across multiple stages.
I'm starting to see how multiple timelines could actually make time travel even more restrictive.
Right.
But wait, didn't we establish earlier that if we saw multiple versions of the time traveler,
Uh-huh.
that would mean multiple timelines?
Yes, but there's a fascinating wrinkle to that idea.
Okay.
Let's go back to our intrepid time traveler, Alice.
He's back.
She builds a TDP time machine and decides to take a trip to the past.
All right.
What if there are multiple timelines,
Okay.
but we only ever see one Alice?
Hold on. How could that be possible? Wouldn't multiple Alices automatically mean multiple timelines?
Not necessarily. Remember those cyclical histories we talked about?
Yeah.
Where timelines leap back around?
Uh-huh.
Imagine it takes 1 hour to travel through the wormhole,
Okay.
but a full day, 24 hours to cycle between histories.
Okay.
Alice steps into the wormhole in History 1, travels for 1 hour,
Uh-huh.
and emerges in History 2.
Okay.
But since the history dump takes 24 hours,
Right.
there hasn't been enough time for an Alice from History 5 to arrive back in History 1 yet.
Ah, I see. So even though there might be multiple Alices hopping between these timelines,
Right.
we might only ever see one at a time.
Yeah.
Because of this time lag between wormhole travel and the time it takes to jump between histories, it's like a cosmic game of leapfrog.
Exactly. It highlights the complexities of time travel when you factor in multiple cyclical histories.
Right.
The timing of those jumps could create the illusion of a single timeline,
Okay.
even if multiple histories actually exist.
And this brings us to a crucial question.
What's that?
What happens if Alice tries to change the past in this scenario?
That's a question that leads us deep into the potential consequences of time travel, which we'll explore in the final part of our deep dive.
All right, welcome back to our final part of this time travel deep dive.
We're in the endgame now.
I know my brain is already fried, but I'm ready for more.
Well, we left off with Alice potentially changing things in the past.
Right, and maybe erasing herself by doing so.
Let's say she successfully changes something significant in a past timeline. Let's say she, I don't know, prevents a major war.
Okay, big change.
Now, each timeline in this model, remember, is like a separate layer.
Our pancakes.
They're connected, but they're independent.
Right, so changing history in one timeline doesn't directly rewrite the others?
Nope, not necessarily. Her original timeline would likely remain unchanged.
Okay, so preventing that war in one timeline doesn't magically erase it from all the others. But what happens to Alice's original timeline if she changes things elsewhere?
That's where it gets really tricky. Changing the past in one timeline could have this ripple effect on Alice herself, even if her original timeline remains intact.
Wait, what do you mean?
Remember, the Alice we see might be hopping between timelines, right?
Right, our cosmic leapfrog.
The Alice who made that change, the one who prevented the war,
Yeah.
might cease to exist in the next cycle.
Whoa, hold on. So Alice might be erasing herself by changing the past, even if her original timeline remains untouched.
Think of it this way. The reason Alice decided to travel back in time in the first place, right?
Okay,
It might be tied to that war happening.
okay.
If the war never occurs,
Right.
the Alice from the original timeline might never have had a reason to build a time machine and travel back.
Oh, wow. So her actions in one timeline can actually erase her motivation for time travel in another, potentially wiping her from existence.
It's a consequence of these cyclical, interconnected histories.
It makes you think twice about messing with the past.
Absolutely. But there's another fascinating layer to consider here.
Okay, lay it on me.
The idea that time travel might leave behind subtle traces or echoes of these multiple histories.
Okay, so like fingerprints at a crime scene, but for time travel.
Yeah, exactly. Let's say Alice successfully changes the past in one timeline, creating a new branch of reality. Even though other timelines remain unchanged, particles from those timelines, right?
Yeah,
They might have interacted with particles from that altered timeline.
I'm confused. I thought those timelines were separate layers, like those pancakes. How can particles from different timelines interact?
Remember those ghostly particles we talked about earlier?
The ones that can pass through each other?
And swap colors as they go? That interaction, right? It isn't limited to particles within a single timeline.
So particles from different timelines could have bumped into each other, leaving behind traces of their interaction, like even after one of those timelines has changed.
Precisely. These traces might be incredibly faint and difficult to detect.
How faint are we talking?
Anomaly in particle behavior,
Okay.
unexpected energy fluctuations,
Uh-huh.
or even slight variations in, like, physical constants.
So you're saying we might be able to find evidence of these multiple histories and the effects of time travel just by looking closely enough at the universe around us.
That's the fascinating possibility suggested by this research. If we could detect these subtle echoes, it would be a pretty strong indication that our universe is far more complex
Right.
and interconnected.
Than we ever imagined.
Yeah.
Wow. So we've gone from simple time travel paradoxes to a universe with potentially infinite timelines, ghostly particles, and a cosmic web of cause and effect that spans across multiple realities. My brain is officially fried.
Mine too.
This has been one mind-bending deep dive.
And the most exciting part is that this is just the beginning.
I know, right? It feels like we've barely scratched the surface.
There's so much more to explore. Who knows what other incredible discoveries await us as we continue to unravel the mysteries of time travel.
Well, I want to thank you for joining me on this incredible journey, and I hope you, our listeners, enjoyed it as much as we did. And remember, the next time you ponder time travel, keep in mind that it might be far stranger and more complex than you ever dreamed.
Definitely more pancakes and syrup than we initially expected.
Definitely. Until next time, keep looking up and keep asking questions. You never know what mind-blowing discoveries are waiting just around the corner.